All right, class, welcome back. This is our last and final objective for chapter 7. So we're in 7.7, talking about complex numbers. And right now we are going to talk about finding powers of I. Okay, finding powers of I. Well, we're going to use what we know. Now we could derive this stuff, but I'm just going to show you. Again, we know that the square root of -1 is just I. And we also know that I squared is -1. Using that knowledge, we could say, okay, well, I to the first power then is just I. And we could say that I squared is -1. Well, then what would I cubed be? Well, I cubed is the same thing as I squared times I. If I is just I, and I squared is -1, then looks like I cubed is actually -I. Okay, so the value of I cubed is -I. What about the value of I to the fourth? Well, I to the fourth we could separate out to I squared times I squared. But we know that the value of I squared is -1. So if I replace those, then the power, the fourth power, I to the fourth power is equal to a -1 times -1, which is a +1. So again, this pattern is just going to keep repeating. If I want to know what I then to the fifth power is, it's just going to be I, because I'm just going to go round and round with this pattern. I to the sixth will be -1. I to the seventh will be -I. I to the eighth will be 1. Let's see if we can figure out why. Let's take I to the seventh, for example. So I to the seventh, we could separate out to I to the fourth times I cubed. We know that I to the fourth is 1, and that I cubed is -I. Well, 1 times a -I is a -I. So again, this pattern is just going to be reiterated. Every 4 is going to repeat itself. So that means that I to the 9th is just going to be I, and I to the 10th is just going to be -1, and I to the 11th is going to be -I, and I to the 12th is going to be 1. Okay, so what would a problem look like in this section, finding a power of I? So we want to just find like the value. So say like we said, well, what is I to the 22nd worth? Okay, easiest thing to do is to break this number down to multiples of 4. We're going to do the Price is Right rules here. So biggest number that would go up to 22, that's a multiple of 4. We do 4, 8, 12, 16, 20. Okay, so I'm going to factor this out to I to the 20th times I squared. Now I'm going to take and rewrite this I to the 20th using the power rule. The power rule says that if I want to raise powers to powers, I multiply them. So if I factored this 20, I would say if my base was I to the fourth, this would be I to the fourth raised to the fifth power. Again, 4 times 5 is 20. I'm using this power rule here to break this down into multiples of 4. The reason why is because I know the value of I to the fourth. I to the fourth is 1, so I can replace I to the fourth with 1. I also know the value of I squared. That is a -1. Well, 1 to the fifth power is 1 times 1 times 1 times 1 times 1, which is just going to be 1. And 1 times a -1 is going to give me a -1. So the value of I to the 22nd is -1 because of this reiterative pattern that every 4 just resets here. Okay, so what if we wanted to know the value of, let's say, I to the 15th? Well, again, I'm going to do like Price is Right rules and try to break it down to multiples of 4 without going over, closest to without going over. So I've got 4, 8, 12, 16. 16 is over, so the closest multiple is I to the 12th. That means that this is I to the 12th times I to the 3rd, because we add these together to get this 15. Again, that's using the rule of exponents, that when you have the same bases, you add their exponents. Whoops, forgot my equal sign. Got too excited. Okay, so I can break these down. Well, this I to the 12th can be written as I to the 4th raised to the 3rd power. That was kind of sloppy there. I to the 4th raised to the 3rd power, again, because m times m, 4 times 3 is this 12. And that's still being multiplied by I to the 3rd. Well, again, I can replace this value of I to the 4th with 1, because it's always going to be 1. And I can replace the value of I to the 3rd with a negative I. Well, 1 times 1 times 1 is just going to be 1, and 1 times a negative I is going to give me a negative I. So the value of I to the 15th, or the power of I to the 15th, is has a value of negative I. Let's do one more, just for good measure. If I had I to the 40th, again, remember, I'm just breaking this down into multiples of 40. Well, of 4. 40 is already a multiple of 4. So I could say that this is I to the 4th raised to the 10th power, because 4 times 10 is 40, using this rule here, using our power rule. So this is the power rule of exponents. This is the product rule. Okay. We've worked with this a whole bunch throughout the semester. So again, I can break this down, and I know that the value of I to the 4th is just 1. Well, 1 raised to the 10 power is 1. So always looking for multiples of 4 without going over playing Price is Right rules. So this is how you simplify powers of I.